So today we are doing proofs using triangle congruence shortcuts, so the stuff we learned yesterday and Friday. Before we get started on the proofs, we just want to see which postulate we would use to prove the triangle is congruent for these first two. So here I have these two sides are marked congruent, and then I have that these two sides are marked congruent. And then we had talked yesterday that when I have angles across from each other like this, those are vertical angles, and they're also congruent. So if I look at this picture, I have side angle side, so that's the congruence shortcut that I would use. On the second picture, I have the top and bottom sides are congruent, and I have the two sides are congruent. And then based on this picture, since they're sharing a side, I know that that side is also going to be congruent. So this one would be by side, side, side. Okay, so here I actually want to fill out the proof tables. On the first one, I have it a little bit filled out for me. It gives me that JK is congruent to LM, JM is congruent to LK, and I want to prove that the two triangles JKM and LMK are congruent. So it says JK is congruent to LM. This first one was given to me. Then I have that JM is congruent to LK. That again was given to me. Then I have KM is congruent to KM. This one was not given to me, but it is a line that is itself. This one is the reflexive property. And then I just have one more thing to prove. I just want to say that the two triangles are congruent. So triangle JKM is going to be congruent to triangle LMK. And I want to say the reason based on this picture. So I had three pairs of congruent sides. This one would be congruent by side, side, side. Okay, on the next one, I have to fill in everything myself. So I have that IE is congruent to GH, and that one was given to me. Then I have that EF is congruent to HF, again, this one was given to me. Then I have F is the midpoint of GI. That one again is given to me. And then I know that because F is in the middle of G and I know that these two sides are going to be congruent. So IF is congruent to GF. And this is by definition of a midpoint. And then now that I have everything labeled on this picture, I can see I have three pairs of congruent sides. So I can say my two triangles are congruent. Triangle EFI is congruent to triangle HFG. My last line should always match up with the proved part. And then my reason here is, again, side, side, side. So I have these two on the bottom. It starts off with BE bisects AD at C. And that one is given to me. I have AB is perpendicular to BC. That again is given to me. Then I have DE is perpendicular to EC. Again, given to me. And then the last thing I have is that AB is congruent to DE. So the only thing that actually gave me something I could draw in the picture was, and the perpendiculars, AB to BC. Then when it says it bisects, that means that it's going to cut it in half. So I'm going to have AC is congruent to CD. And this is by definition of bisect. Then looking at my picture, I have a right triangle with a hypotenuse and a leg, so I can say that these two are congruent. Triangle ABC is congruent to triangle DEC. And this is by hypotenuse leg. Okay, so on my next one I have triangle ADC is isosceles. That one is given to me. Then I also have that BD is perpendicular to AC. Again, given to me. So because these are perpendicular, I know that these are going to be right angles. So that is going to be the measure of angle DBA equals 90, and the measure of angle DBC equals 90 by the definition of perpendicular. Okay, then I know that this line is going to be congruent to itself because it's the definition, or not the definition, it's the reflexive property. So DV is congruent to DV. Okay. Then, because it told me it was isosceles, I know that AD and DC have to be congruent. This is from the definition of isosceles. Then I can say my two triangles are congruent because I have the hypotenuse and a leg. So I have triangle ADB is congruent to triangle CDB. And this is by hypotenuse leg. But this question is not asking me to prove that the triangles are congruent. It wants me to go a step further and to say AB is congruent to BC. So I can say that. That's going to be my 7th step. And the reason for this is corresponding parts of congruent triangles are congruent. This might be abbreviated as CPCTC. So on the back side, I have this triangle. It gives me that AC is congruent to DE. Then I have angle ABC and DCB are right angles. This one and this one. That was again given to me. Then based on this picture, I can tell that BC is going to be congruent to BC because it's the same side. So this one is by the reflexive property. And then, because these are right triangles, I can tell that they're congruent. So I have triangle ABC is congruent to triangle DCB. And this one is by hypotenuse leg, because they are sharing, or the hypotenuse are congruent, they share a leg, and then they're both right triangles. I have these extra lines I don't need. Okay, and then I just have 2 more examples where the tables aren't written out for me. So the first thing I'm given is angle A is congruent to angle D. Then I have angle B is congruent to angle E. Also given to me. I have AC is congruent to DF. Again, given to me. If I look at these, I have angle, angle, side. That was one of our shortcuts we learned yesterday. So I can say the two triangles are congruent. Triangle ABC is congruent to triangle DEF. And I said angle, angle, side. So in this next one, I have angle M is congruent to angle K. This was given. I have WM is parallel to RK. So that's these arrows. This was given to me as well. So remember when I have parallel lines, a line that intersects them both is a transversal. So I can say that this angle right here and this angle, oops, wrong one. This angle right here are congruent because they're alternate interior. So that is angle MWR. And that is going to be congruent to KRW. These ones are by alternate interior angles. And then right now I only have two pieces on my picture. I can say that this line is congruent to itself because it's the reflexive property. So WR is congruent to WR. Now I have three pairs of congruent items labeled on my picture. Angle, angle, side. So I can say triangle WMR is congruent to triangle RKW, and by angle, angle, side.